Okay. November 2020, paper 1, variant 3. Yeah. Question 1. Student uses a meter ruler to measure the length of a sheet of paper. Which measurement is shown to the nearest millimeter? Is shown to the nearest millimeter. Which of these measurements is shown to the nearest millimeter? Hmm. Yes, it is C. It is C. It's shown to the nearest, okay, millimeter. Um, B is shown to the nearest centimeter. A is shown to the nearest decimeter. Okay. D is not shown, it's not shown to the nearest millimeter. Okay. Yeah. How can the motion of the object be described? How can the motion of this object, distance time graph? This is a distance time graph. How can the motion of this object be described? Initially, initially, the object was it moving at a constant speed or was it at rest? Initially, the object was at rest. Yes, initially the object was at rest. Why? Because this is distance. Yes, this is a distance time graph. So initially it was at rest and then it was moving with a constant speed. It was at rest and then it was moving at a constant speed. Why did I say it's moving at a constant speed? Because it's a constant slope. Constant mm, slope, constant gradient. Okay. Yeah. An athlete runs 300 meters up a hill in 100 seconds, and then she runs down the hill in 50 seconds. What is her average speed? What's her average speed? Average speed equals total distance over total time. This is easy. Average speed, yep, total distance. What's the total distance? Total distance over total time. She runs up the hill, which is 300 meters. Is this the total distance? No, it's not the total distance. The total distance would be, again, running down the hill, which would be another 300 meters. So 300 meters up and then 300 meters down. Total time is 150. 100 plus 50. So 600 divided by 150 is 4 meters per second. 4 meters per second. Hmm. Which quantity is shown? No, which quantity is shown? This is quite easy. The mass of the object. Which quantity is a weight an example of? Weight is an example of definitely a force. يعني. Uh, which answer? You're talking about 3? 3 is B. Okay. 3 is B. Yeah. A student is asked to predict whether a solid floats in liquid or not. Which density does the student require? Okay. Which density does the student require? Uh, You need which information? I'm sorry. Which the information is about the density. Yes, the information is about the density, and you need both the densities of the solid and the liquid. Okay, you need the densities of the solid and the liquid. Hmm, يلا. The diagram shows a car moving along a road. Hmm, a car moving along a road. What is the motion of the car? The force due to the engine is 1,500 newtons and the total drag force is 200 newtons. What's happening to this car? Hmm. What's happening to the car? Definitely the car is increasing its speed. The car is definitely increasing the speed. Why is it increasing the speed? Because the forward force, yes, the forward force is greater than the backward force. Yeah, the forward force is greater than the backward force. So the forward force is great when the force to the right is greater than the force to the left, it would increase the speed. Yes. Hmm. So let's see. Hmm. Question 8, student Y and student X. or on a seesaw. X has a weight of 400 newtons and Y has a weight of 600 newtons. The seesaw is in equilibrium. Okay, the seesaw is in equilibrium. Which statement correctly describes why the seesaw is in equilibrium? Why is it in equilibrium? The resultant force is zero and the resultant moment is zero. صح? We know this. We know that equilibrium means that the resultant force has to be zero and the resultant moment has to be zero. It has to be A, yes. Okay, any questions? The diagram shows a frictionless pendulum. Pendulum bob swings from point P through point Q to R and then back to P. At which point is the energy of the pendulum, okay, the greatest? At which point is the energy of the pendulum bob the greatest? Hmm. Point Q. Okay, someone's saying B, point Q. Did did the question specify, for example, did he say at which point is the gravitational potential energy the greatest? Or at which point is the kinetic energy of the bob the greatest? Or did he just say the energy of the pendulum the greatest? The energy of the pendulum, when I say the energy of the pendulum, and I do not specify what type of energy, then I mean the total energy of the pendulum. And the total energy of this pendulum would be equal to the kinetic energy of the pendulum plus the gravitational potential energy of the pendulum. At any point in this pendulum, P, Q, and R, the total energy of the kinetic energy plus the gravitational potential energy would be equal. So, for example, at P, the kinetic energy plus the gravitational potential energy would be equal to the gravitational potential energy plus the kinetic energy at Q, and the same applies for R. Okay, gravitational potential energy plus the kinetic energy, they would all be equal. So the total energy is the same. The total energy remains constant. This is due to the law of conservation of energy. Energy cannot be created nor destroyed. It can only change from one form to another. In this case, it changes. It constantly changes from gravitational potential energy to kinetic energy from any point, moving from P to Q to R and back to T. So at P and Q and R, the total energy remains the same. Total energy remains the same. If if he did specify, for example, the greatest gravitational potential energy would be at P or R. The greatest kinetic energy would be at Q. Okay. Hmm. Which statement correctly compares the production of electricity using wind and the production of electricity using nuclear fission? Using wind and using nuclear fission. Hmm. Wind is more or less reliable. Definitely, wind is less reliable. Wind is not more, it is less reliable. They are both renewable. Is the wind is renewable? Yes. Is the nuclear fission renewable? Nope. Wind is less wind is less reliable. Wind is renewable, but the nuclear fission is not. Yes, the nuclear fission. I'm sorry, it is not. So it is B. Yes. Okay. Hmm. To calculate the power produced by force, the power produced by a force, the size of the force must be known. What else needs to be known to calculate the power? Power equals work done over time, which is force times distance over time. We have the force, we need the distance, and we need the time. We need the distance and the time. So it would be A. Hmm. Okay. Question 12 is cancelled, has been removed. Question 13. 12 is cancelled. Question 13, what is the pressure on the floor? What is the pressure on the floor? This is a really nice question. Let's solve it together. Okay. Why is it a nice question? A large box has a weight of 700 newtons. Pressure equals force over area. Pressure equals force over area. But if you check out the answers are newtons per meter squared. Newtons per meter squared. They're all newtons per meter squared. And the dimensions of the box are in centimeters. Dimensions of the box are in centimeters. So you cannot just calculate the area by multiplying 70 times 50. This would be completely wrong. This would be completely wrong. You have to, okay, you have to change the dimensions to meters. How can I change it from centimeters to meters? You have to divide by 100. So the width would be 0.5 and the length would be 0.7. Again, you cannot just multiply 70 times 50. You have to initially change them. You have to convert from centimeters to meters. Dividing by 100, the width would be 0.5 and the length would be 0.7. خلاص, this is the area. So force is 700 divided by the area, which is 0.5 times 0.7. Okay. The pressure would be around 2000. Hmm. Any questions, any problems with this question specifically? Hmm. يلا شباب, any questions? طيب. Yeah. On a warm day, a driver checks the air pressure. Okay. At night, the temperature drops. The temperature drops at night. Why does the pressure decrease? Why does the pressure decrease? Hmm. Yes, when the temperature drops, what happens to the air molecules? Uh, the air molecules move more slowly. When the temperature drops, what happens to the air molecules? They move more slowly. So this is why the pressure drops. Okay, good. ماشي. Hmm. Okay. Textbook gives the description of thermal process. The more energetic molecules escape from the surface of a liquid. Hmm. What is this process? And this is a very easy process. When they escape from the surface of the liquid, this is called, definitely it's called evaporation. Hmm. Which physical property changes when the temperature is measured? Okay, this has been removed. Liquid in glass thermometer. This has been removed. Okay. Two different pure substances, X and Y, are heated. Both substances are initially in a solid state. The graph shows how the temperature of each substance changes with time. How the temperature of each substance changes with time. What does the graph tell us about these substances, X and Y? Hmm. What does the graph tell us about these substances? Again, they both initially had um, they were both in a solid state. Hmm. What can we learn from this graph? Hmm. It's quite easy. Substance X and Y. يلا, any ideas? Hmm. Nothing? Ah, yes, exactly. This is correct. It would be substance Y has a lower melting point because initially they were solids. So temperature keeps on rising, temperature keeps on rising until it reaches the melting point. So substance Y has a lower melting point than substance X. It's quite easy. Okay. Lower melting point. Hmm. Question 8. X and Y. The air temperature and the density. Okay. The air temperature and the density. At which points is the air temperature higher? This is a radiator, it's a heater. Okay, it's a heater. At which points is the temperature higher? Definitely at X. The temperature is higher at X. I'm sorry. Temperature is higher at, X. So it could be A or B. The density, okay? The density at X, the density is lower at X. Why? Because the temperature is higher, but the density is higher. Density is higher at Y because as the air cools down, the density increases. So it should be B. Yes, it should be B. Yeah. Question 19. Which thermal process can transfer energy through a vacuum? The only one is radiation, infrared radiation to be more specific. Hmm. Which row correctly describes light waves? Light waves. Are they longitudinal? No. They have to be transverse. And how do transverse waves travel? Perpendicular. Yes. They do travel perpendicular to the direction of the wave travel. Yes, up and down. A transverse wave. Hmm. Any questions? What are the amplitude and the wavelength of the wave? Hmm. Amplitude is, it has to be, the amplitude has to be, no, the amplitude is not two. No, the amplitude is not two. This is wrong. The amplitude has to be one. Why does it have to be one? Because this is the mean position. Okay. Mean position. So the amplitude is the distance from the crest to the mean position or from the trough to the mean position, which would be 1 meter. This is the amplitude. The wavelength, yes, it is two. Yes, the wavelength is two because 6 divided by 3, we have 3 wavelengths in this case. Okay. 6 divided by 3 is 2. So it has to be B. Okay. A boy is having his eyes tested. The letter is printed on a card and placed over his head. He sees the card in a plain mirror, okay, on the far wall of the room. He sees R in the mirror. He sees R because he sees R in the mirror. How is the print? How is it printed on the card? How is it initially printed on the card? Yes, this is correct. It has to be B. Why? Because the mirror laterally inverts the image. Okay, mirrors laterally invert the images. So it has to be B. Yes. C and D are definitely wrong. And you cannot see R as it is in the mirror. It has to be inverted, laterally inverted. Hmm. A man sees a stone at the bottom of the pool. Which path could be taken by the light? Yeah. Which path could be taken by the light? Hmm. A is wrong. C is wrong. The only path could be either B or D. D is wrong. Why? Because as the stone or as the light moves from the water to the air, what happens to the light? It has to increase. The angle of refraction has to increase. It cannot decrease. This is the normal. Oh, this is the normal. This is the angle of incidence. How can the angle of refraction be less than the angle of incidence? This is definitely wrong in D. So the answer would be B. Yes, the answer is B. Okay. Diagram shows the image made by a converging lens. Which statement describes the image formed? Which statement describes the image formed? It's not upright. It's not upright. It is inverted. Is it enlarged? No, it is diminished. It's smaller. Okay, it is smaller. Yes. Hmm. Okay. Yeah. Diagram shows 3 types of electromagnetic radiation listed on a particular in a particular order. Which quantities increase? Okay, which quantities increase in magnitude going from left to right? Which quantities increase moving from left to right? Microwaves, infrared, X-rays. Huh? The only quantity that increases is yes, it is the frequency. Only the frequency. The speed never increases. Okay, the speed is the same. Police car with its siren sounding is stationary. Pedestrian notices that although the loudness does not change, the pitch varies. The loudness does not change, but the pitch varies. Which row describes the amplitude and the frequency? Again, the loudness has to do with the amplitude. So when the loudness doesn't change, this means that the amplitude is constant. صح? The amplitude is now, why? Because the loudness has not changed. When the loudness does not change, this means that the amplitude is constant. What about the pitch? Pitch has to do with the frequency. So when the pitch varies, the frequency varies. So the frequency is varying, but the amplitude is constant. It would be B. Okay, it would be B. Hmm. Hmm. This is an interesting question. Diagrams 1, 2, and 3. Okay. Which row explains the readings on the balance? Initially, we had a magnet and the reading was 125.3. Magnet 1 and magnet 2. Diagram 2 is 124.9, which is slightly less. Diagram 3 is 126, which is slightly greater. Polarity of 1 and polarity of 2. X, uh, X has to be, yes, X has to be South Pole. It has to be a South. Why does X have to be a South Pole? Because it attracts it upwards. It attra- X has to be a South Pole. Why? Because it's attracted upwards. But Z has to be a North Pole. Why? Because it's repelled downwards. So the magnet in diagram 3 is now repelled downwards, and the reading on the balance increases. Reading on the balance is now slightly greater than the reading in diagram 1. Why? Because it's repelled downwards. So south and north, which would be uh, both of them are repelled. لا, this is wrong. They are not both repelled. Okay, magnet 1 attracts. Magnet 1 attracts. Okay, the magnet. Why? Because the reading is less, because the reading is slightly less. But in diagram 3, the reading is slightly more. That's why, okay, that's because it's repelled downwards. It's kind of pushed downwards. Has to be seen. Okay. Which diagram shows the directions in which the compass needles point? Which direction is correct? We can cancel out C and D. You can just cancel out C and D. Why? Because you can never have a compass needle pointing upwards or downwards while in this position, while between the north and the south pole. Okay, you cannot have this. This is definitely wrong. So is it A or is it B? Okay, it has to face the south pole. Why? Because the direction is moving from north to the south, so it has to face the south pole. So it would be A. B is wrong. Okay, cannot face the opposite side. Okay, yeah. Which statement about charging an insulator is correct? Charging an insulator, which statement about charging an insulator is correct? Hmm. It can be given an electrostatic charge by placing it on a magnetic field. No. By connecting it to a battery. No. Okay. By friction. Yes. By friction between two non-metals, by two insulators, a dry cloth, for example, and a plastic rod. Hmm. Each diagram shows part of a circuit. The circle represents an instrument. Which row is correct? Okay, the unit of potential difference. Okay, we need to measure the potential difference. Which of them would measure the potential difference, and what is the unit of the potential difference? Potential difference is yes, it is the voltage. It has to be measured in volts. Which diagram is correctly shown? Diagram 2. Yes, because it has to be in parallel. It has to be in parallel. Which two ammeters read the largest current? Largest current would be in, yes, in P and Q. P and Q. Yeah. Three statements about a relay are given. Which statements are correct? Which statements are correct? This is an interesting question. This is an interesting question. A relay has a coil that becomes a temporary magnet when it is in operation. This is correct. How does the relay function? There is a coil which becomes a magnet. Yes, this is correct. A large current in a relay is used to switch off a small, no, wrong. Actually, a small current, which is in three, a small current in a relay is used to switch on a larger current. Yes. This is the operation. Why do we use a relay? Why do we use a relay? Again, what is a relay? It's a device which uses the magnetic effect. It uses what? The magnetic effect. Why does it use this magnetic effect? To be able to use a small current to switch on a larger current. And that's all you need to know about the relay. That's all you need to know about a relay. It has a magnetic effect. Why does it have a magnetic effect? Because it has a small coil. This coil acts as a magnet when a current passes through it. Are you required to pass a large current through the relay? No. You're actually required to pass a very small current. And this small current could could operate on a larger circuit. It could switch on another circuit. It could switch on a much larger circuit. So it would be 1 and 3 only. It would be C. Okay, yeah. An electrical appliance is powered from the main supply. The appliance normally uses current of 3 amperes. It briefly rises to 4 amperes, and the cable is designed to withstand currents up to 6 amperes. What is the fuse we should choose? Which fuse? Which of these fuses should be in the circuit to protect the circuit? The appliance normally uses 3 amperes, so you cannot use 3 or 1. This would be definitely wrong. You cannot use 3 or, and the cable it can withstand up to 6 amperes. So the fuse must be greater than 4 and less than 6, which would be 5. Okay, it has to be greater than 4 and less than 6. Okay, when a metal wire moves up, cutting a magnetic field, an electromotive force is induced. 33 again. Okay, again, the appliance uses 3 amperes. This is the normal operation. For example, let's say the laptop. For example, the laptop needs 3 amperes for the laptop to operate smoothly. It needs 3 amperes. If you add a fuse which is 3 amperes, what will happen to the fuse? It will blow up. It will instantly blow up. Why? Because the fuse or because the laptop will take the 3 amperes. Sometimes it could take up to 4 amperes, which is normal. Okay. If you have a device that, let's say, an air conditioning unit, okay, let's say this device takes up to 10 amperes. Okay. Normally, it could take up to 11 or 12 amperes. It will not blow up. Nothing will happen to this device. Okay. So the fuse must be greater than 12 amperes, for example, for the air conditioning unit. For this device in this question, The fuse must be greater than 3 and 4. Why does it have to be greater than 4? Why does it have to be greater than 4? Because it briefly rises up to 4. Briefly, okay, every now and then it rises up to 4. So will I blow up the fuse every now and then? No, I don't want to blow up the fuse that often. Okay, so what should I do? I have to have the fuse which is greater than 4, but the fuse has to be less than 6. Why does it have to be less than 6? Because the cable, the wire, okay, the cable, the wire, if the current exceeds 6 amperes in this cable, if the current exceeds 6 amperes in this wire, what will happen to the wire? It will melt. It will cause, due to what? Due to the overheating. It will melt. So the fuse has to be greater than 4 and less than 6. In this case, it is 5. Okay. When a metal wire moves up, cutting a magnetic field, an electromotive force is induced. Okay. It is generated, induced in the wire, which change affects the magnitude of an induced EMF, which change affects the magnitude, the size of the induced current or of the induced EMF. At the same speed? No. Faster? Yes, this is right. Okay, faster. When you move it faster, it will increase the induced EMF. It will increase the induced current. Transformer needs to convert 240 to 4800. Which pair of coils? This is a step up transformer. Step up transformer. Which pair of coils would be suitable? Okay, step up. So the NP and NS, number of primary, okay, number of coils, number of turns in the primary coil, number of turns in the secondary coil. NP and NS, 500, 50, 1000, 240, 48,000. We can cancel out C and D. We can just cancel out C and D. Would it be A or B? Very simply, we can write down the equation NP over NS equals VP over VS. NP over NS equals VP over VS. If you calculate VP over VS, 240 over 4,800, this would be the same as 50 over 1,000, which is A. If you calculate, for example, 240 over 48,000, it would not give you the same answer as 240 over 48,000. Okay? It's a simple trial and error question. Trial and error. Okay? Yeah. Diagram shows a wire carrying current. There's a magnetic field. The wire experiences a force out of the page. What does this? The force on this wire is now out of the page. So this wire is moving out of the page. The current is now reversed. When you reverse the current, what happens to the direction of the force on the wire? Instead of it being out of the page, it would be into the page. When you reverse the direction of the current, what happens to the direction of the force? It is also reversed. So it will be, yes, it would be into the page. This is correct. Which statement is correct for the nucleus of any atom? Which statement is correct for the nucleus of any atom? Yeah. The nucleus contains electrons. The nucleus contains the same, no, it doesn't have to contain the same amount. The nucleus has a total charge of 0, no, it's positively charged. D is right. The nucleus is very small compared to the size of the atom. How many protons and how many neutrons? Number of protons, 90. The number of neutrons would be 144. 234 minus 90 is 144. Which row describes the readings and the cause? The readings and the cause. Okay, a radiation detector is measured, okay, is measuring the background radiation. The readings vary with no pattern. Yes, that's background. Why? Because it's random. Okay, random background radiation. So they vary with no pattern because the background radiation is random. Okay. Yeah. Last question. What is the half-life of the substance? Again, 1000 divided by 2 is 500. 500, which would be 5 years. Okay. Question for 39 is A.